Hey guys, it's Mrs. McLean, and we are going to be looking at our proportional relationships. And we're not going to take too much time on this because, quite honestly, you have an awesome math teacher, and she's already been working with you on proportional relationships for a while through warm ups, lessons. We have talked about this so many times, so it should be a quick review. So, right now we've got Julie and picking some teammates for our flag football team. So, we're just going to complete this table. And I can see that up here, I know that she picks 3 girls for every boy. That's the situation we have. So just filling it in. 1 boy means 3 girls. 2 boys means 6 girls. Well, let's fill in another one. 3 boys means 9 girls, and 4 boys means 12. You can see I highlighted right here for you that every time I'm getting a number in my X column, I'm just multiplying by 3 each time. And just in case you don't remember, that's what we call that constant rate of change, which is also known as our slope. Remember that word? So we're going to go ahead and just graph it like they asked us to. And you can see it starts at 0, 0, because if she doesn't have any girls and no boys, that would be our 0, 0 point. And I can then put on there from my chart my 1, 3, 2, 6, 3, 9, 4, 12 points. Draw a straight line through it. That means it is linear. And since it does go through that 0, 0, we know it's proportional. So it says let's find the ratio of the girls to boys. Now I want you to be very careful because when they say ratios, doesn't always mean the slope, that y over x. You have to look for the word to. That's the ratio that they're looking at. Girls, they want that to be on the top. Boys, they want that to be on the bottom because of the order they gave it to us in. So girls, which was our y, over the number of boys, which was our x. Now I hope you remember that rise over run, the y over x, is also what we call the slope. And then what I'm doing is just taking that table and putting in those numbers. 3 over 1, 6 over 2, 9 over 3. And notice when I reduce them all, it should all come out to that 3 over 1. So it shows us that constant rate of change. Now, filling in those boxes between the relationship of the girls and the boys. Number of girls are y equals 3 times the number of boys. Now remember when we were working way back when this year on that equation y equals kx when it's a proportional relationship, and that k was the slope, or what we call the unit rate? Well, that's exactly the form you just did. Y equals 3 times x. That 3 is that slope or that unit rate for this problem. So let's go ahead and use that same exact equation, they said, to find out how many girls there would be if she actually had 10 boys. Well, now that we have that formula, y equals kx, which you can see here, y equals 3x, put in that 10, and you know that would give you that answer of 30 girls. What if it was 18 girls? Well, your girls are your y. Taking that same exact equation, this time though, putting in 18, and then solving for x by dividing 3 on both sides, should give you that x is going to be, or the boys would be, 6. And that shows us that proportional constant, that same constant. 2 vocabulary words, which again we've already worked on before. The constant of proportionality, or the proportional constant. And again, that is the ratio of each y to the corresponding x value, that y over x. And of course, unit rate, which we have talked about before. Unit rate. Now, this one says unit rate of y with respect to x is the amount of y that corresponds to 1 unit. It is true, that's the academic vocabulary definition, but we said it's when you have that y over x and that x is a 1. So number 2, which is going to be like problem number 2 on your homework, is giving us another problem with dry ice and root beer. Now again, here it's asking for you to, let me get a different color, write a ratio for the proportional constant. And again, doesn't matter which is y or x, you have to look at the question they gave you. And the question that they're asking is the number of pounds of dry ice to the number of ounces of root beer. So again, that 2 right here is what you have to be very careful about. So whatever's in front goes on top, whatever comes after the word 2 goes on the bottom. So you can see that dry ice is on top, root beer on the bottom, and from our problem up here, 12 pounds of dry ice for 8 ounces of root beer is where I got that 12 to 8. Reducing it shows me my ratio is 3 to 2. Now in this next problem, again, look what they have here. Number of ounces of root beer, this time to the number of pounds of dry ice. So this time I want the root beer on top and the dry ice on the bottom. Still using that information from the top, that would give me 8 over 12. And of course, reducing that gives me a ratio of 3 over 2. So the answer you're going to get for that ratio depends on what they ask. And I put it right here. Be very careful to find when they say to find a ratio. Look what they're asking for. That too is really telling you the order. Now if I said I want you to find the slope, that always has to be y on top and x on the bottom. So let's go ahead and make a table for that root beer and dry ice. Again, here I can see my root beer is going to be my x. My dry ice is my y. So if you don't put in anything of either one, remember that's our 0, 0 origin. That's showing a proportional relationship so far. Now, let's go ahead and fill in what we know. Well, the ratio of that y to x we know is 3 over 2, and we got that ratio right up here. So I know that's what my ratio is for 1 ounce of root beer extract. Again, 2 would be 3. 3, well, if you're not quite sure, you just multiply it by that 3 over 2. So that's going to go ahead and give us 4.5. 6, well, do the opposite. I could divide by 3 over 2, and that'll give me 4. And 12 to 8, or 8 to 12. Again, how can I get this number that I'm multiplying everything by? Again, that's my ratio. So when we go ahead and graph this, 0, 0 point, 1 is 1.5, 2 was 3, 3, we got 4.5, 4, we got 6, and then they gave us 8, which is over at that 12. So now go ahead and connect those dots. And you can see with that, we had that 0, 0 and a nice straight proportional line. It's linear. Now let's go ahead and look at some candy here. We've got a 4th of July parade, and we know there's some saltwater taffy. And at the grocery store, it was 3 pounds for $15. And I hope you remember, when we talk about money, money always goes on top. So when they're asking us to find that unit rate, remember we need to go ahead and put the money on the top, and then the pounds can go on the bottom. If I want a unit rate though, this denominator has to be a 1. The only way to get it to be a 1 is to divide both top and bottom by 3. And of course, I'm going to get my $5 per pound. Now when I go ahead and put it into my equation, you know if this is the unit rate, this is my ratio. That is the unit rate, which means I'm going to multiply everything by 5. So this is where I've got these 5s down here. my unit rate. So if I have 1 pound, it's $5. 2 pounds, 10, 3, 15, and 4, 20. And then if I wanted to use the equation, well, you know the equation is y equals kx, and that k is my unit rate or my slope. So when you put it into that nice graph, which I already graphed for you right here, you can see again, it's linear, it's a nice straight line. It goes through that origin, which means it absolutely is proportional. So if I use that nice equation, y equals 5x, and now I want to know how much would it be for 5 pounds, I'm going to go ahead and put that 5 in for x, and you will then get $25 for 5 pounds. You can also use these proportional relationships to compare. So when she sees there's Tootsie Rolls at the store and that saltwater taffy, she can go ahead and find the unit rate of that Tootsie Roll by taking the $26 over 4 pounds, which is what I got from my information. And I find it's $6.50 per pound. Obviously, that's a little more expensive. So you know the Tootsie Rolls are more expensive than the saltwater taffy. But if you didn't know the actual price and you only had a graph, which I put the saltwater taffy on here and the Tootsie Rolls, you can see just by comparing, Tootsie Rolls is higher than the saltwater taffy graph. Your slope is larger. Your unit rate is larger. That's why it's on this higher line right here. So if I only had the graph to compare, I would easily be able to say Tootsie Rolls is definitely more expensive than the saltwater taffy. And that's where we got that answer. So we're going to be working with this again in class. I just want to do a quick review just on the kind of problems that we're going to be working with. Again, we've done proportions so many times before. This should be pretty simple and a nice little review. We're just going to be using a little bit more of our real world situations to try to compare and use that proportional relationships. Come with your questions and we will review it in class. Have a great day.